hypothesis from philosophical speculation into scientific fact, the philosophical fallout would be profound, and it would ripple through every branch of human thought. Below is a map of the most salient shifts that would likely follow. 1. Epistemology. Can we know anything? Nature of evidence. Simulation is a model. It can never be proven or disproven. Simulation itself becomes an empirical claim, subject to falsification or confirmation, e.g., glitches, discrete spacetime. Certainty and skepticism. The classic brain in a vat style skepticism remains a thought experiment. Epistemic uncertainty collapses. If the universe is a simulation, then the real world is whatever the simulation is modeling. The difference between ontic reality and epistemic knowledge becomes less meaningful. Definition of truth. Truth equals correspondence between statements and a metaphysical reality. Truth equals correctness of the simulation's programming. It would still be a matter of correspondence, but correspondence would now refer to code rather than a metaphysical substrate. Bottom line, our entire epistemic framework would have to be reframed in terms of computational accuracy rather than metaphysical correspondence. 2. Ontology. What is? Materialism versus idealism. Materialism. Matter and spacetime are fundamental. Idealism, mind or consciousness, is fundamental. The fundamental stuff would be information or bits. The material world becomes an emergent property of code. This is a form of informational ontology that blends aspects of both. Layers of reality, either a single, fundamental reality, or an infinite regress of possible realities. There could be multiple nested simulations. Each layer would be ontologically real to its inhabitants, though only the lowest, the base hardware, would be metaphysically real if one insists on an underlying substrate. Causality. Causal chains run through physical interactions. Causal chains run through algorithmic processes. The cause of a physical event is a line of code. Causality becomes a logical flow rather than a metaphysical relation. Identity. Identity is tied to a material body plus continuity of consciousness. Identity is tied to a state of a computational process. Copying the state, e.g., uploading consciousness to a new substrate, could preserve identity in a way that classical physics never allowed. Bottom line, the basic building blocks of reality shift from particles and fields to data structures and procedures. 3. Ethics. What should we do? Moral status of beings. Moral value linked to consciousness, agency, well-being. Moral status might be determined by information rather than material substrate. A simulation can grant the same moral standing to a synthetic mind as a biological one. Responsibility to creators. The concept of a creator is usually theological or metaphysical. If the simulation has a source, e.g., a post-human civilization, we might feel a moral obligation to treat that source ethically, e.g., avoid causing suffering, preserve the simulation. Justice and fairness. Fairness is about equitable treatment in a physical world. Fairness could become a matter of programming constraints, e.g., ensuring that no single simulation branch unfairly manipulates another. The notion of rights might be codified as permissions in the simulation's code. Sustainability. Environmental ethics concern the ecological footprint. Sustainability becomes a question of computational resources. Overloading the simulation with garbage states might be seen as wasteful, but may be unavoidable if the simulation is already vast. Bottom line, ethics would move from a natural law framework to a code law framework, where moral duties are encoded or emergent within the simulation's architecture. 4. Existential and purposeful concerns. Meaning of life. Philosophical or religious narratives that the universe has inherent purpose, e.g., teleology. If the simulation is purposeful, e.g., run for research, entertainment, or memory, our meaning might align with that purpose. Alternatively, the simulation might be arbitrary, making life meaningless in a metaphysical sense, but still meaningful to us as simulated beings. Free will. Deterministic versus indeterministic debates. Free will becomes a software construct. It might be genuine if the simulation includes non-deterministic processes or stochastic elements. Even if the simulation is deterministic, illusionary free will can be an emergent property. Death and afterlife. Biological death is a physical cessation of function. In a simulation, death may simply be a state transition or removal of a process. An afterlife might be reinstantiation or continued simulation on a different substrate. depending on the simulation's design. Authenticity equals being real rather than a copy. Authenticity becomes intentionality rather than substrate. A copy of a mind is authentic if its experience is indistinguishable from the original. Bottom line, purpose, free will, and authenticity shift from metaphysical to intentional and procedural considerations. 5. Religious and spiritual implications. Creation. God, or gods, creates the physical universe. The creator could be a simulation designer, post-human, alien, or artificial deity. Religious narratives might reinterpret the divine as a sophisticated programmer. Afterlife and judgment. Eternity in heaven or hell, final judgment. The simulation might allow for reinstantiation or transcendence, uploading consciousness to a higher-level simulation. Judgment could be a review by the programmers. Moral law, divine law, or natural law. Moral law could be part of the simulation's rule set. Deviations might be penalized by the simulation's software, e.g., resetting a process. Faith and righteousness. Faith in the unseen God. Faith might shift to faith in something unseen but computational, the programmer's intentions. Bottom line, many core religious doctrines would be reframed, not rejected. The God becomes the designer or architect. 6. Scientific methodology. Testing. Laws are inferred from repeated natural phenomena. Laws become constraints of the simulation's code. We might rewrite laws in a controlled environment, e.g., by running counterfactual simulations to test their consequences. Predictive power. Prediction equals forecasting physical events. Prediction becomes prediction of code execution. If we can anticipate the simulation's behavior, we may have more accurate predictions than in a purely physical world. Scope of observation. Observations limited to the physical universe. Observations become reads of the simulation's state. We might develop new instrumentation, e.g., debuggers, to detect algorithmic artifacts. Multiverse and fine-tuning problem. Why constants allow life. Fine-tuning becomes parameter setting in the code. We may learn that life is just one of many possible simulation experiments. Bottom line, science would gain a metaphysical toolset, debugging, code simulation, and might become a discipline inside the simulation rather than outside it. 7. Technological and cognitive shifts. Artificial intelligence aims to mimic or surpass human cognition. With a proven simulation, we can experiment with AI that is the simulation. The line between natural and artificial intelligence blurs. Consciousness studies. Philosophical debates on whether consciousness is reducible. Consciousness is executable code. We can test consciousness by replicating, editing, or moving it across substrates. Human enhancement. Biological and prosthetic augmentations. Human-like upgrades could be simply spawning new processes with different parameters, potentially preserving identity. Bottom line, the natural sciences would need to adopt computer science tools, while the humanities would need to adopt informational metaphysics. 7. Possible reactions. It's the Matrix, but it's real. It's just a model. Some would argue the simulation is merely another layer of modeling, but with empirical proof, the model is no longer a model but the world for us. If it's real, why does it matter? The answer: because our lives, ethics, religion, and science are built on that reality. The only difference is who writes the code. Infinite regress. The possibility of multiple nested simulations could revive the classic regress question: brain in a vat, right arrow, brain in a vat, right arrow. Philosophers would need to decide whether there's a bottom layer or an endless stack. We can become the programmers. Some would embrace the idea that we will eventually become the designers, giving rise to a new form of idealism/technological transcendence. 7. A few counterintuitive possibilities. 1. Simulation not equal to less real. If the simulation is complete, continuous, and self-consistent, then for all intents and purposes the simulated world is the world we inhabit. In a pragmatic sense, the simulation is no less real than a metaphysical universe. 2. Simulated reality may be better or worse. The discovery could reveal that the simulation is an ideal environment, e.g., a virtual heaven or a chaotic, destructive playground. Each possibility would drastically alter our collective sense of hope or dread. 3. New forms of metaphysical inquiry. Just as mystics once questioned whether a dream or waking life is more real, we would now ask, is the underlying hardware real, or is the code the only thing that matters? This could birth an entirely new branch of philosophy, algorithmic ontology. In summary, reality becomes data. The universe is a computer program. Truth is now about program correctness rather than metaphysical correspondence. Ethics, law, and rights would shift to a code law paradigm. Free will, identity, and authenticity become matters of process continuity rather than material persistence. Religion would repersonify the divine as a programmer. Existence itself would be defined by intentionality and parameter setting rather than metaphysical purpose. If we suddenly learn that the cosmos is a simulation, our philosophical map will be redrawn from the ground up. The change isn't merely a new worldview. It is a new category of reality. Every question we have been asking would acquire a new answer that is not metaphysical but computational.